Hello, this is Mike at GameFromScratch, and welcome to another SFML tutorial. Today we're going to be looking at playing music. I was going to do music and sound together. They're very similar, but there's some slightly different things I want to cover in each one, so I decided to split this out. But the first thing we should probably talk about is why there's a music class as opposed to a sound class. If a music file is in fact a sound file, which frankly it is. Here's the class hierarchy from the SFML tutorial or the documentation. And you can see here both the SF sound class and the music class inherit from sound source. So there's a lot of common functionality between them. So what's the difference? And the hint is this guy right here, the sound stream class. It's an intermediary class. And what it boils down to is music files are intended to be streamed. They're not loaded into memory, so they're considered probably longer, more compressed audio files. Think basically your music library on your phone or your desktop. Whereas SF sound files are actually loaded into memory and intended to be played quickly. The process is a little bit different. The sound files go through a buffer, whereas the music files are streamed. But otherwise, it's a very similar process. So, as I said earlier, we're going to jump in and just do the music stuff today. As always, there's a text-based version of this tutorial available on GameFromScratch. I will link it below. And also, I assume that you've seen all of the previous tutorials in this series or understand the content covered. So if we go through something and you don't understand it, make sure you check the previous tutorials. And if you still don't know at that point, ask me a question. I may have screwed up. That's always very possible. So that's what we're going to do today. Now, in order to get started with music, there's a few things we've got to change from what we've done to this point. I'm reusing my trusty project here. You can see our standard code, pretty much the exact same we've used all along. Let me just go ahead and run it, make sure I didn't create any errors in my cut and pasting. All right, there you go. So simple starter application. What we need to do now, though, is change the dependencies a little bit because we're also going to be using the SF audio now. And that just means coming into your linker settings here and input. And you want to make sure, so far we've just been linking to the graphics library and then the window and system library, the required library of SFML. So let's also add in SFML audio-d.lib. Really, that's it. So we just need to make sure that the audio library is linked in and done. So now we can go ahead and use it. It's a new include file that we need, and it's #include, and I bet you can guess this one. SFML audio HPP, like so. And that's it. And now we're going to look at loading a music file. And a music file, as I said a little while back, is streamed from disk. And it can be supported in a number of different file formats. Instead of listing them all for you, here they are. So, of that list, I have heard of OGG, WAV, FLAC, AIFF, RAW, VOC, and I think that's about it. So, I'm not an audio guy. I don't know the merits of the majority of these formats. All I can really tell you is that FLAC files are rather large, but incredibly good quality sound. OGG is pretty much the open source replacement for encoded files, and WAV is generally very large. So the rest of these formats, I couldn't tell you why you'd use them and why you wouldn't. But one thing I can tell you is there's no Mp3 support. If you look at that list, you might be thinking, well, why is there no Mp3 support? And basically, it boils down to the Mp3 license sucks. Thomson Media is the patent holder on the consortium of patents held by Mp3, and basically they started licensing it out. A bit of a Trojan horse license situation there, so people generally stay the hell away from Mp3. There is a free-to-use license for it, but it's a little odd. I think it's around... if you ship less than 5,000 products, you don't have to get a license, otherwise you do. And a lot of times, if you can use MP3 with your game engine, they're either ignoring the licensing completely, or they've paid the licensing fee for you. If they haven't, again, you can be caught with this annoying patented encumbered format. So that's why SFML does not support it. Now, if it comes down to it, and all of your sound files are only in MP3 format, there's an excellent free program called Audacity right here. It's available at I don't know, Google Audacity. It's a great program, and turning your MP3 into an OGG file is literally a matter of open MP3, export OGG, and done. So with that said, we are going to need such files. So as you can see here, I've actually converted this MP3 to this OGG file. And if you look over here, if you can see it, the MP3 file is 10 meg. The OGG file is 4.3. So there are some other advantages to using OGG. Generally, it is smaller than MP3 with very comparable sound quality. So I'm just going to grab this guy here, and we'll bring it into our project. Right here. So I'm going to just go ahead and create a new folder called audio, and we'll dump our OGG file in. So our OGG file is goats_typical American, a very obscure, relatively unheard of, but excellent 1992 rap band. And this is what we're going to hear. So that's the sound you want to come up in the background. So now that we have a music file to play with, let's head on back to our code and use it. So this is going to be laughably easy, actually. So right off the hop, we need a music file to load it into. So we can load it. It's sort of just like working with the images. We can load it from file, memory, or stream. In this case, we're going to load it just from file. And remember, I put it in the subfolder audio, and it's called goats_typical American.ogg. Now, one thing to be aware of here is I'm running on Windows, and obviously there's no case sensitivity to the files. But on your Linux or Mac install, that might be different. So be careful with your file casing. I'm not sure how SFML actually handles case on files, but I know the underlying seedlight will say not found if the case doesn't actually match original source. So just be wary of that. So that's it. Now I'm not going to blow your ears out. So let's set the volume. So set volume takes a value between 0, which is no volume, and 100, which is full volume. So we'll go with halfway there. And then finally, play. And that is it. So in theory, I go ahead and run this. And there you go. There's our song playing. Hopefully that comes through properly through Camtasia. It's a little strange about audio at times. But that is our audio playing. All right, so now what we're going to do is we're going to take a quick look at changing the volume of it as we go, and we're also going to look at fast forward and rewind. Now, fast forward and rewind is going to introduce us to another concept of SFML, which is our built-in time classes. Dealing with time can be a little tricky at times, pun not intended. So the nice thing is they bundled in SF time and a bunch of associated functions we can work with. So we're going to look at jumping forward 5 seconds at a time using the SF time classes. So first things first, let's handle the keyboard. And you know what? I'm just going to be lazy and copy and paste this in because you really don't want to watch me type keyboard handling code. So I will walk through exactly what we just typed. But basically, if the key is pressed, we check to see if it's the up or down volume, up or down arrows. And if it is, all we're doing is getting the current volume and either adding or subtracting 10 from it. It's the same logic as here, but we're doing it driven by key presses. Now the important part here is tracking. Now here is if you press the right arrow. If we press the right arrow, what we want to do is jump forward 5 seconds in time for our music. Whereas if you press the left arrow, we're going to jump back 5 seconds. And you can see the logic is right here. So get playing offset returns us an SF time, which represents the current value. And we can do add, multiply, and divide, add and subtract to our time values using the built-in method. So there's an SF seconds, there's other ones, such as milliseconds and microseconds. I don't know if there's hours. No, there's not. So you can increment by set amounts just using the standard plus operator right here, and then we're just going to update it with our new position. You know what? This is probably superfluous because it should actually be an SF time. Yeah, so it is. And oh, CO isn't defined. All right. So that include Iowa stream. And go ahead and run that. So now there we are, playing as normal. If I press up, our volume increases. Okay, I have a bit of a logic error in my copy and paste. Ah, yes, I have a very big logic error in my copy and paste. So that was firing a whole lot because I wasn't putting it actually inside the event handler. So let's try that again. So up arrow, you'll see over here, our current volume goes to 60, 70, 80, 90, 100. So we're at full volume right now. Coincidentally, you can go to 110. Here, I'll go back down to 40 or so you can hear me. You can go up past 100, it just doesn't do anything. Now you can't go below 0. And in fact, here's an oddity that I've seen. So look at our volume. So we're at 30, 20, and then when I do one more down, I go to 9.9998. I don't know why. But then in the next step, we want to make sure we don't go past 0. So we've got, and you can see here, there's an error that comes in if we actually go below that amount. So I don't know why this rollover occurred. It's very, very interesting, but not really overwhelmingly important. But anyway, so you're setting your volume is literally just a value between 0 and 100, very straightforward. Now your positioning, on the other hand, is the left and right arrow. So right, we're going to fast forward. You can see we're at 44 seconds in, 41, 36. And then we'll go right back to the very beginning. Beginning, 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 5 seconds, beginning, 5 seconds. So, tracking through a song is trivially simple. And I think that's about all I'm going to cover for now. Now, you might be wondering, is there any logic in there for detecting song ending and similar functionality? No, there really isn't. It's not built in, but it would be easy enough to add. And one thing I didn't really touch on in this example is your control over the audio itself. So when you've got your song file, you can do play, pause, and stop. So you have VCR style controls over how your audio is playing. And get, which one is it? Status. And this will return if it currently is playing, is stopped, is paused. So you do have some control over that. So basically you could just do like a, what do you actually return? Sound source status. So you can do your logic that way, that easily, no problem at all. The other thing that I didn't really cover on here is you can loop your song if you really wish. Like so, and it will now play over and over and over and over and over again. Now I put a 3-minute song in here, so I'm not going to demonstrate that this looping actually works, but looping actually does work. Now that is it for music. Not a really difficult concept at all. The only thing you got to watch out for is music itself is not copyable. So you need to create a new version of it. You can't do a copy C++ style. It's actually prevented. And if you destroy the contents of music while music is still alive, music gets very pissed off at you. So those are really the only two gotchas, and they're pretty common sense. So make sure that your music is actually unique. If you want, you can actually load it from a new file if you want to change things, or you can actually have one music per song you're playing. And you know what? Having multiple musics per song isn't really a big deal because it is streamed out. Unlike sound, it's not loaded into memory, so there's not a huge impact from having multiple music files. So you could have an array of music that basically represents your soundtrack if you wish. There's no problem in doing that. So that's it. That is playing music in SFML. Stay tuned. We will be covering playing sound, and part of playing sound will also be applicable to playing music because there's something we didn't touch on here, which is like positional audio, and music is also capable of that. As I said earlier, they've got the same base class and they've got a lot of the same functionality. So Some of the stuff we'll look at in the next tutorial on playing audio is also, or sound, sorry, is also applicable to music. So stay tuned. Hope you enjoyed that. See you later.